Good afternoon, everybody. Welcome to SoundWaves. For those of you who've been to a SoundWaves event in the past, thank you very much for coming back. And for those of you who are new to SoundWaves, welcome. Welcome also to the Wisconsin Science Festival. There's lots going on in the next 4 days, so please come back and check out the huge variety of stuff that's happening here. All of it will be absolutely fascinating, and I'm sure you'll discover a lot about the world. Hopefully things that you had never even thought to ask will become clear to you. This program, SoundWaves, is a program which is just motivated by some basic questions that I have about the world. I'm a wonderer, and in the case of today's program, I'm wondering, why do we often agree when things are beautiful, when people are beautiful? We look out at a mountain and we all think it's beautiful. Why do we even have that concept? Why is music beautiful? What does beautiful even mean? Why is there ugliness? And is ugliness always ugly? That sort of thing. So we're having a sort of a scientific, aesthetic experience today with an extremely distinguished panel of scientists and musicians. Thank you so much. And everyone should have a program which has the names and names of the speakers and titles of their talks. And we will be projecting the text to the songs on the screen during that portion of the program at the end. It's possible that some people who are behind the piano lid will want to move in order to see those texts, and we'll give you just a second to do that. So without further ado, we will start with Bas Rokers, Professor of Psychology, and thank you again.
Thank you for that introduction, Dan. Thanks for having me. Let's make this. All right, that works. Good afternoon. So to set this up, I was hoping to take us back a little bit. So I'm a visual neuroscientist. I'm a professor in the Department of Psychology here as well as in the Netherlands. And so some of the things that you'll see coming by will have a little bit of a Dutch bias because of my affiliation with the Netherlands. So I hope you will forgive me for that. In order to make you appreciate this talk even more, I'm going to try and hypnotize you to some extent. Okay, that's not the entire truth. So I am a visual neuroscientist, and I specialize on motion perception. And so some of the things that I'll be showing you today will be basically pointing out that we don't always see what we believe we see. And so what you want to do while you listen to the sound of my voice is focus on basically the center of this image. So look at the center of this image while you listen to my voice. And this totally works. So visual perception obviously requires the eyes, but a large part of visual perception actually happens in the brain. And so as I speak, there are cells in the back of your brain, in visual cortex, that are firing vigorously. They're really excited by visual motion being shown on the screen and you looking at it. Now these cells are so excited, in fact, that they're getting really tired or they're getting really fatigued. And what will happen is that at some point, they'll get so tired that they'll stop firing. And so in a second, what I'll ask you to do is stop looking at this, not yet, but in a second, and look at the back of your hand. So we'll see the effect of this fatigue, of this neural fatigue, while you look at the back of your hand. So you guys all ready? So 3, 2, 1, look at the back of your hand. All right, so to be sure, I didn't do anything to the back of your hand, right? So I didn't go around and make sure that everything was moving. But what hopefully most of you saw is that your hand appeared to have some sort of motion that you've never seen your hand do before, right? There was some sort of undulation on the back of your hand. This is, in fact, neurons in the back of your brain firing and telling you something is there, which in reality is not there. Or I hope that it's not there because we would all have to go to the emergency room right now. And so this is a simple demonstration to show you that we see things that are not there, or we can see things that are not there. Right, so can we also do the opposite, so the reverse? Can we not see things that are there? Now, anybody who has been looking for their car keys knows that this is true. But that's kind of a trivial example, right? Because there you're not actually seeing them, and that's what you're looking for. It turns out that this is actually a much worse problem than you would think at first sight. This is a famous picture, it's apparently hung upside down, as everybody can tell. But everybody recognizes this, I hope, as the Mona Lisa, painted by Leonardo da Vinci. It turns out that that is not exactly what this picture is. It looks perfectly fine, right? And so what I'm saying is I'm illustrating the fact that we often do not see things that are there. So let's look at this picture right side up. So it's not quite what you were seeing before, right? I didn't actually, of course, there's digital projection here, so I could be like messing with you in the meantime. To convince you that that's not the case, I'll rotate it again. This is what you were looking at initially. Looks perfectly fine, right? Let's just, for the critics or for the skeptics in the audience, let's go back, do it again, and we'll do it again. All right, so again, to illustrate that we often do not see things that are there, right? So what we should do is we should say, well, this is not the picture that I think it is. There's something very weird and disturbing about this picture. That's not what actually happens. And so the issue here is that we are all visual experts. That sounds really good, but it's actually a problem when it comes to seeing things as they are. And so when you go to beauty or art, you start seeing, or you start getting an idea of why this might be a problem. If we do not see things as they are, it becomes very hard for us to reproduce them or to paint them. So in a way, our expertise is getting in the way of us seeing things as they are. There's a movie that's actually going to be coming out. It's been in the festival circuit for a while now. I think it's going to come out at the end of this year, called Tim's Vermeer, which is about a independently wealthy individual who was going to try and replicate the paintings being painted by Vermeer. And he has a specific theory about it. He has a theory about why Vermeer could make things look the way that they really are instead of the way that they seem. And so he's going to tell us about this now.
When we look at a white wall, our brain and our retinas tend to interpret it as a solid color, right, even though it's infinite shades. Yeah. And it's happening right in our retina. There's image processing going on inside our retina.
It's actually in the eye.
Yeah, and this is local contrast enhancement that's going on that helps us see into shadows. So evolutionarily, it helped us avoid predators and see prey.
Right.
It's
a motion detector.
And it's a motion detector also, but it's also just trying to eliminate the effect of shadows.
Right.
Well, these walls that Vermeer painted had accurate shadows.
And they shouldn't.
They shouldn't. You can't see them. His contemporaries would make a lame attempt at putting a shadow on, but Vermeer nailed it just the way a video camera sees it. And that's what got me going. And I go, there must have been a machine he could have used to do that. It's the only explanation. So I went home and I did this experiment on my kitchen table where I propped up a photograph and I put a panel down flat on the table to paint on, and I set up this mirror at a 45-degree angle, tiny mirror on a stick. So I'm looking down in the mirror, and in the reflection in the mirror, I see the photograph. If I look off the edge of the mirror, I see my panel down on the table. I took some paint and I put it on the panel. And now, right at the edge of the mirror, I can compare those two colors very accurately. Oh, wait, that is way too bright. Mix in some black.
Wow.
Okay? Once you've got it mixed and it's the proper color, the edge of the mirror goes away. So if it's too bright, you can see the edge of the mirror. If it's too dark, you can see the edge of the mirror. If it's exactly right, you can't see the edge of the mirror.
All right, so what he's pointing out is that to some extent, or this is a hypothesis that has been advanced for a while now, for the last 20 years, that Vermeer and people of his time in the Golden Century were using tools, using scientific tools to actually get the artistic beauty in their paintings that they try to achieve. And so one of the examples he uses here is, how do you get color just right? So it's often the case that when we see a color, we are very bad at reproducing that color because we don't see it correctly. And so I'm going to illustrate that again because, again, I'm a visual scientist. I put a little dot on this figure to help you focus. So it's the same idea as I was doing before. While you listen to the sweet sound of my voice, fixate at that location. And so this is going to illustrate that sometimes you will actually see color that's not physically there. Right now that will sound a little bit cryptic, but just like there's motion cells in the brain, there's also color-sensitive cells in the brain. These color-sensitive cells are not so much interested in telling us what the exact color of something is. They're more interested in telling us what the color difference is between either adjacent locations or adjacent time points. And so what they're going to be telling you is the difference between the color that you're seeing now and the color that I'm going to show you in a second. And what that's going to mean is that this difference is going to be overcompensated. So in locations where right now you're seeing, make sure you don't actually follow my laser pointer, make sure you keep fixating at the center. Where it's this ochre color, you're actually going to overcompensate, and you're going to see its complement color, which for some of you, as you may know, will be blue. So in a second, I'm going to show you a picture. And again, there's no special tricks that I'm using here. It's just your visual system. I'm just employing your visual system. So here we go in 3, 2, 1. All right, so this is a little bit more of a subtle effect, but I think all of you got it. So as soon as we switched, I showed you a black and white image. Now that's not actually what you saw. What you saw is a color that's an image that was vividly in color, which hopefully that is what you should have seen if you fixated, where the sky was a very nice blue and the grass over here was a very nice green. Those colors were not there. And so the brain is actually very bad at telling us instantaneously what the color of some object is. So again, what's there is not always the same as what you see. And so this is an issue that you have to overcome if you're a painter. Just to convince you once again that I'm not playing any tricks, I'm going to go back real quick. If you go back and forth like this, you'll get the same effect, but it will be much faster, right? So you see a little bit of color, and then immediately it goes away. All right, so one thing that an artist has to do when they start painting is they have to start to unlearn seeing as we commonly do, which is meaning to interpret everything that we see. And we have to start seeing things the way that they are, which sounds very straightforward. This is how we go around the world, and we feel like we immediately grasp the way things are. Hopefully I've illustrated to you that that's a myth that your brain perpetuates because it's actually a useful concept to have. And so it's not just the case for color, it's the case for many visual properties. So it's the same for shadow, which Jennison talked about a little bit in his video. Texture and perspective as well. And perspective turned out to be particularly problematic and took a long time for artists to figure out how to properly render that. Once you understand how to render that, you can actually start playing with it, right? But it took us a very long time to go from Renaissance painting to something like this by Escher, where locally all the perspective cues are correct, but he's playing with it in such a way to break it. But you first have to understand it before you can break it. So perhaps what to take from my talk so far is that art and beauty are at the intersection of things as they are and things as we see them. So we can find beauty in things especially exactly because they point out the difference between what we see and how things really are. And so maybe this is, this is another example of that. I'm sure everybody agrees that this is not physically possible. There is no such thing in the world. But it somehow, to me at least, conveys something about how things really could be perceptually, right? How color contrast works in a particular way. So that's all my time. If you're interested, if you're interested more about my research and more about visual neuroscience, my website is up here. And I'd be happy to answer any questions after everything has happened. I'll be around. Thank you very much.
Well, good afternoon. My name is Jennifer Angus, and I'm a professor here in the Design Studies Department. And my very brief talk, I've been given 5 minutes, and it's a good thing I'm an artist because I'm going to show you pictures and hope that each one is worth 1,000 words. Since this is so brief, you can go to my website to see more about my work. And in this brief time, I'm going to speak about beauty in unexpected places. Oops. Now, some of you may know that I am the insect lady. For better or worse, that is my title around Madison. And for the past 15 years, I've been working with insects as my medium for art. I work with creatures like this. This is actually an insect from the phasmid family. Common name is the thorny stick or the jungle nymph. It's a female, and in the insect world, girls rule for the most part. They are much larger than the males. And I work with cicadas like this. This is a tropical species, and when its wings are open, the wingspan is nearly 8 inches. And this friendly-looking fellow, I sometimes work with insects like this. In fact, this fellow has become quite important in my work, the Latin name Titanus gigantum. You can look at these creatures thus far and see how those Japanese monster movies were inspired. But it's really what I would like to do today is show you insects in a very new way and perhaps see the beauty in it. So in design studies, I teach textile design, and specifically in the print and dye studio. So everything I teach is about pattern. So of course, I take insects and I pin them to the wall in patterns that mimic wallpaper. And these are very elaborate environments. Of course, they suggest a very grand place in this particular slide, a kind of palace. They surround you, and most people, when they walk in, they don't know. They go, oh, the fancy wall is pretty elaborate. And then when they get up close, they make this discovery. And admittedly, sometimes I do see people take a step back as they realize what it is, because we think we're seeing something we know, a fancy wallpaper. So that suggests someplace nice, cozy inside, but what's that one thing we don't want in our house? Bugs. So I'll answer the most common questions I get asked. Are the insects real? Yes, they are. Is this their natural color? Yes, it is. Did I collect them myself? Sadly, no. They come from insect specimen dealers. Lots of people collect insects. Most people want 2, a male and a female. Obviously, I need considerably more. So I'm going to barrage you with some images so you can see the scale, the magnitude of some of these installations. And the insects, if you're wondering, they are reused and reused for every installation. When the show comes down, they go into foam boxes. Most of the things that you see with wings in my work are not butterflies. They are cicadas and grasshoppers. And there are many layers that you can read, sort of interpret my work on. But I think one of the things I'm trying to do is rehabilitate the image or insects that I've said already, we take that step back. So we associate them with dirtiness, disease, decay. But really, we could not live without insects. They are so important to our environment, obviously for the pollination of fruits, fruits primarily, and the decomposition of matter. We need them or we wouldn't exist at all. So you can see, these are pretty amazing creatures. And even the most terrifying insect is really quite remarkable as we can look at the veins in these wings of the cicada or the incredible adaptation of the jungle nymph. She may have looked fierce before, but here it's really quite amazing. And then, of course, you can make fierce patterns with the insects, as I have here. Now, one thing I've observed is that a lot of people don't like insects, and many don't want to step into the room. But when they see them in patterns, they're okay with it because it's a kind of control. It's an organization, and of course that's what man seeks to do, is control nature. We are far less comfortable when we see them like this, what I call the swarm. Another tactic I've taken is anthropomorphizing insects. Enacting fairy tales, here we have the princess and the pea. And this was a big decision, who was the most beautiful to be the princess and the most handsome to be the prince. And then Rapunzel, well, unfortunately, there are no insects with lovely golden hair, but she has pretty great pigtails, I'd say. I certainly take a lot of inspiration from the Victorian era, time of great collecting, and when science was shared with everyone. It was very popular through a lot of books that told scientific facts, but through a narrative. And so that's one of the things I also pursue. I call this piece Planet of the Apes Insect Style. So the roles are reversed. Insects are in charge. People being sold at market. They brought their market baskets. Here they're being let out of the cages and made to entertain. I like this juxtaposition of female beauty versus insect beauty. The insects, as I said, get reused, but when things break, then I make other creatures. And we have a lovely cicada lady here. And finally, I said that that very large insect with the pinchers is important to me now. I've actually published my first novel this March. It's for middle school readers. Search for the Goliathus Hercules, in which a boy discovers he has the ability to speak to insects, and he goes on a journey to find this particular one. And I leave you with this. It's a quote from the author Toni Morrison: "Birth, life, death, each took place on the hidden side of a leaf." So maybe next time you're thinking about scuffing on an anthill, don't do it. Don't take out the fly swatter or the raid. Thank you.
There's an exhibit of insect art here at the table, and I hope when we're done with the program, everyone will walk by here and take a look.
That one, okay, thanks. Thanks, Dan, for inviting me to come here. I was looking for ways to connect, and I'm thinking, sound waves. Well, there are a lot of waves in life, and I like the use of metaphor. So when on my way here, I go to the airport looking for something to read on the plane, and the first thing I pop up is Gravity Waves, October issue. And I thought that's pretty amazing. Do you think? Or I don't have to go anywhere. I can stay right here. I was just going to move that book there. Don't hang that on there. Okay. Is it all right? Is that better? I'm sorry. This way? Okay. Oh my, that sounds loud to me. Loud is good, okay. Well, since I'm from out of town, you are new to me, but I am so excited about interdisciplinary challenges. There are ways of thinking outside your normal realm, and to try to connect in here, I've already get excited about seeing Boss's work with visual art and also with Jenny's. There are connections, that's for sure. I wanted to, when I was talking to a friend of mine who is a musician, I said, what am I going to do? I'm supposed to talk at a some sort of music presentation. Oh, girl, you're going to be speechifying. And I thought, oh dear, I better write it out. So I did write it out, and I think it'll go faster if I kind of read it. I wanted to go back and try to search for some of my early source and of inspiration. And I had to go back to a real early source, and that is from the symbolist, French symbolist poet Verlaine, Paul Verlaine. And I think you may even know this. I'm just going to read a little bit. But it's a poem where he's guiding you as a poet to write. It's called The Art of Poetry. Can you hear me okay? Okay. You must have music, first of all, and for that a rhythm uneven is best, vague in the air and soluble, with nothing heavy and nothing at rest. You must not scorn to do some wrong in choosing the words to fill your line, nothing more dear than the tipsy song where the undefined and exact combine. It is the veiled and lovely eye, the full noon quivering with light. It is in the cool of autumn sky, the blue confusion of stars at night. Never the color, always the shade, always the nuance is supreme. Only by shade is the trothel made, between flute and horn, and dream with dream. There's our connection. So each of us sort of sees, I think, beauty in our own way. That's what we think of as a truth, but we're each giving form to use, and the artist has subject, content, and form. So I'm going to try to talk a little bit and weave those all together. Our design classes give us some basic, this is in what Jenny's teaching, the design classes give us some basic words to kind of hold on to as young students, and they are rhythm, harmony, movement, balance, all those and unity, of course, and that relates back to music. And I think that my work will show that too. This first work is called Making Waves. It's a lithograph. And with the title that you've given, SoundWaves, Making Waves as an opener sounded like a good one. I look for connections in nature. Titles are wonderful touchstones. They can be mysterious, or they can have double meanings, which is one of my favorite types. It's important to me to give good titles to art. It's important for me, it's important for the viewer, and instrumental for them. I look for connections like watching the wind hit ocean waves. I work in collage and print media both. I bring images from different sources together, creating new relationships and meaning. In this lithograph, Making Waves, the fans are drawn from a Japanese sash, embroidered sash, and the beach scene is taken from an old health book. I connect art and life through metaphor. What is making the waves in air, in water, or in life? There is usually an implied narrative with some ambiguity and some mystery, I hope. That's the bottom one. Where do you aim it? I'm sorry, where do you aim it? Thank you. This lithograph is more direct and simple. It's called Tides. It's about rhythm and change, about nature evolving in our life. Change and flow is really constant. There's a necessity to find certain rhythms that work in life and in art for beauty's sake. Smooth as glass with that arrow. This pastel rhythm of the waves is a more tumultuous and complicated composition. Certain balances are in question, and you rock through the sea. All is resolved in the end, though. Is there an end or a beginning in painting? There is in music, isn't there? This is a collage, solid theory. The images and background pieces cut precisely to fit into its faceted space. It is an ode to the mathematician and astronomer Johannes Kepler, who at the end of the 16th century sought an ordered beauty of the solar system based on Platonic solids. It's a beautiful model and a gift of the great geometer. I was intrigued by Kepler's spiritual necessity. Science and religion had a special relationship then. I've included this mixed media collage. It's an example of a more complicated composition. It's packed with many interrelated images in 4 major divisions. It causes your eye to move from one part to another, looking for connections. Those are those quiet spaces in the center where the cloud, auspicious cloud is. A place to catch your breath. The collage was inspired by the word auspicious. The auspicious moment, the right time to do something. Looking into its source, the word goes back to Roman times when it was important to read the signs of nature before acting. Were those positive signs, those auspicious clouds in the center? Today we still look for signs and reasons why things happen to us. Was there a cause? Was it chance? Or was it maybe both? We as artists and scientists are trying to order the world around us. We make connections to experience with our arts and sciences and give form to thoughts and feelings. We seek to find a connection with others through the innate qualities of beauty based in us as a part of nature. We enter into the creative process and wind up with an expression of some part of us. Here are 2 lithographs. Left, elements about an artist seeking order in chaos, and right is regards rolled. A portrait of your next speaker, Roald Hoffmann, who also searches for beauty in chaos and often finds order too. Thank you. Do I dare touch this thing? Sorry. I don't want to make a horrible noise. I don't want to make a horrible noise.
And one is one that we've had all along because human beings were put on this earth to change it, to transform it. And that is that chemistry is the art, craft, and business, before it ever was a science, of substances and their transformations, symbolized by this symbol A plus B going to C plus D. And the arrow is just as important as the substances. Now, what makes things beautiful first on this sort of macroscopic level about chemicals? And one of the things is their color and crystals. So at left you see some solutions. They're all of one element combined with others, but with a different number of electrons on that element. It happens to be vanadium. And at right is actually a mineral, vanadinite, a lead vanadate that forms these beautiful, almost candy-colored crystals that you see there. In order to really show you what chemistry is like, you will have to come back on Saturday morning when Rod and Bassam and I have some fun with demonstrations. Now, I was pretty sure that this place would not allow me to have a flame here. And so I had to show you some slides. So here are two elements. They were not there in this form 200 years ago is about when these were made. Bromine, that reddish-brown liquid with a gas above it, beautiful colored at right, aluminum. The tip of the Washington Monument was made of aluminum. It was so precious in the first 70 to 80 years of its existence. Napoleon III served his best dinner guests on an aluminum plate, his second best guests on gold. It was valuable until 1885 when a young man in Indiana, Illinois, found a way to make it cheaply, and a young Frenchman did too. One of these is placed into the other. You see a flame, smoke, foul odors, absolutely everything you expected of chemistry. And at the end, there is something fundamentally different. This is chemistry, this is transformation, this is what attracted artists and all kinds of people. This is what is behind why the philosophers of alchemy made chemistry their way to get into people's minds with, because it symbolizes fundamental transformation and something which we both desire and are deeply afraid of. This is a part of what is chemistry. If you want an impression of the joy of this, you need to look. There is no better place to look than in the work of somebody who is not a chemist. And this is Oliver Sacks' Uncle Tungsten, Memories of a Chemical Boyhood, which tells the delight in the transformations. Now, of course, in a real laboratory, whether it is in a laboratory a block and a half away from here, a scene that you see at left perhaps, or in the laboratories of the chemical industry, explosions are not the way to go. They waste things, and energy is wasted, and substances are wasted, and things are done in a very controlled way as efficiently as possible. So the flames are not there for the most part. Transformation, fundamental and essential, takes place also in the living world. Here is a spring scene of a lilac. There is transformation taking place there, going too slowly and perhaps too fast, but still in a time that we can perceive. The lilacs bloom and then they fade away. And that is also chemical transformation in the biological realm. Now, that is for macroscopic things. And now we have to move into the microscopic realm, and there, perhaps this is the way to do it. So, chemists, through 200 years of frenetic activity, have brought into the world about 70 million new compounds, okay? 68 million of them are white crystalline solids, like you see here. Now, one of these is salt, one is sugar, one is tetrodotoxin, the deadly principle of fugu, the puffer fish, and the fourth one is penicillin. Are you going to play Russian roulette with these by tasting them? If you don't know, your body knows. And 1 milligram of the tetrodotoxin will kill you. So, it is 68 million of those 70 million look like this. So we have to look inside. And then eventually we learned how to do this. And this so that chemistry became the art, craft, business, and then science of molecules and their transformations, because we learned, very interesting, we learned in a way of knowing without seeing, without waiting for microscopes to show us what was inside. We learned what was inside, and that's interesting by itself. We learned that inside are atoms, and much more interesting than atoms, a boring set of 92 or so, just like the Lego blocks that your children play with are boring. What's interesting is what your children build with the Lego blocks. So what's interesting in chemistry are molecules built of atoms. And these now, there are some, here are some. I show you some, and shaped like platonic solids, like a tetrahedron, a cube with hydrogens going out from the carbons, a dodecahedron of carbons with hydrogens going out, and then at lower right, a molecule which should be on a flag of Brazil, shaped like a soccer ball. And this is C60. Are these real? No, these are models. These are ball and stick models. The things are actually vibrating. They're a representation of reality. That's all they are. The moment I show them to you, these things which are beautifully simple and simply beautiful, I feel guilty. And the reason I feel guilty is that I know there are other molecules. Here's one with 9,500 atoms. 4,500 hydrogens, 2,500 carbons, 700 odd nitrogens, and equal number of oxygens, 12 sulfurs and 4 irons, and it looks like a mess. I try to simplify it. I strip away all the hydrogens in this plasticky model, which shows the helices of the biopolymer that is the basic carbon and nitrogen chain that runs inside. It still looks messy. Whether I look at it this way or this way, it still looks like a clump of pasta congealed from primordial soup. It looks like a tapeworm quadrille. This helps a little bit. The platelet shape, what I'm showing you is the most beautiful molecule in the world, which is hemoglobin, the oxygen carrier in our blood. And it's at those little disc shapes, which are in green over here, at the center of which there is an iron atom, which is where the oxygen binds. And this has nothing in the world to do with simplicity. So I feel guilty because these guys, which took a long effort to make, these guys have a direct beeline into my soul or your soul. I don't have to tell you that they're beautiful. But someone had to take me by the hand to show me the beauty of this molecule. So what this is telling me is not something about reality. It's telling me something about the human mind. And that is that the human mind falls for simplicity every time you give it that. And some of it is good, and some of it is not so bad, is not so good at all. But let's look a little bit at another view of this simple complex dichotomy, which is one characteristic of molecules. Oh yes, and where is chemistry? Is it on a polyhedron that I showed you, the platonic solids? Or is it on the side of hemoglobin? Well, it's both, but usually it's squarely in the middle. I mean, here's a molecule which has entered the armament of anti-tumor agents, and this is Taxol, and it comes from the bark of a yew tree, and from the bark of a single yew tree, killing that 300-year-old tree, you can get 3 doses of this drug. Obviously, this is not going to become an anti-tumor agent of any value if you have to kill all the yew trees in the world to get it. So now we come to the other side of chemistry. You have to make it in the laboratory, synthetically, in order for it to be useful. But the first time it came from, and here it is at right. And, it doesn't look very pretty, but it's not as messy as hemoglobin. It's somewhere in the middle, and that is where a lot of chemistry is. What I wanted to do was to move upscale, up 12 orders of magnitude, 12 powers of 10 from the world of hemoglobin, or that cube. That hemoglobin is across it 10 to the minus 7 centimeters or so across that hemoglobin reality. You go up 12 powers of 10, you get to the scale of buildings, of architecture, and you saw, incidentally, something very architectonic, architectural, structure-like, that's all I mean, in this, or in this, for that matter, the architecture of nature. And now we come to the architecture of human beings, and by God, the same thing is being played out. What I mean by that is that the simple and the complex contend in our minds for being called beautiful. So here is an example of the simple. I could have shown you the Parthenon in Greece. I could have shown you a Palladian villa, but this is a high point of Islamic architecture, Taj Mahal in Mughal India. The bilateral symmetry is obvious. Again, I don't have to tell you it's beautiful. But then you go here. We're now in the Cathedral of Toledo in Spain. And this is a high point of Baroque, Rococo architecture. There is the Transparente, an incredible space rising above the altar, and there are figures around it. And by God, if any line can be made curved, it will be in this. This is the Baroque, and that is also beautiful in its complexity. There is the altar at right itself, which is also a miracle. Or we could go elsewhere. 100 years ago, Antonio Gaudi, this is the gatehouse of Park Güell, a building that looks different from every angle as you look around it. Not the same. This is as far away from Bauhaus architecture as you could get. And this is the architecture of the complex over here. So, what is beauty? Is it this simple in molecules or buildings, or is it the complex? Well, I think it's somewhere in between, and we can get there a little bit to that definition of beauty by looking at a few other things. I've chosen them architectural, but it was just there just as well in a Taxol, in that intermediate structure molecule as well. This is a temple, a classic temple from South India, and there is incredible variety in the figures. I don't have a detail of it here, but you notice that they are put onto a pyramidal structure, which has some simple symmetry. Maybe I can tell the whole story better. Up in Park Güell, there is a park. It's a park, and there is a yard with a dirt floor to the right, and then there's a fall-off that you see to the left, and there is a balcony. There is rather a set of seats around in this balustrade around, and there is a mosaic made by Gaudi's architect friend Jujol, designed by it. And you look at this, and let's see, what about it? Where is it on the scale of simple and complex? It's got element of both. You'll notice that the general shape is ordered, that it's not a straight line set of benches. That would be boring. Curved lines are inherently more interesting than straight lines. I'm not going to get into the reasons why. But the other thing is the mosaic. You notice that some of them, there are simple geometrical figures, like circles, but there are some others. And some of them are filled by some random filling of colors, except that this is an artist choosing the colors. And but some of them are filled, like there's a circle filled with black that you see over, oops, that's not what I want, over at lower left, and it's filled with some broken shapes. As you look at this, part of the reason that this is interesting is that we think about why is the artist doing that. So that there is that thought element, there is an inherent color sense the artist has. I'm now not talking as an artist, but as an outsider looking at it. And there is the thought about why he or she is doing it in that way. So this is, let me first show you what Immanuel Kant said about this. He who feels pleasure in the mere reflection about the form of an object, ... This sentence goes on. I skipped about 5 lines. And I assure you that it's worse in German than it is in English. But actually, University of Wisconsin in its philosophy department had some expertise in Kant, and this was from an article I published in an aesthetics journal published by that department a while ago. He who feels pleasure in a mere reflection upon the form of the object justly claims the agreement of all men and women, because the ground of this pleasure is to be found in a universal, although subjective. So beauty is in the eye of the beholder, but he claims something universal. Condition of reflective judgments, that is, the purposive harmony of an object, whether a product of nature or of art. That is, things can be beautiful whether they're natural or whether they're man or woman made. Purposive harmony of an object with the mutual relations of the cognitive faculties, the imagination and the understanding. What he's saying is there is something, I think he's saying the same things that I said about the mosaics there. That is, part of the beauty is in the inherent object, beauty or shape of the object, which the artist psychologically recognizes, but part of it is also in the artist allowing us to share the thought with him and her. And so the intellectual cognition is very important in this. I can say it in another way. Where does beauty reside here? It's not the same thing I'm going to say. So where does beauty reside? It does not reside in simplicity. It does not reside in chaos. It resides at some tense edge between simplicity and complexity, between order and disorder, and in what a human being does with that. And also it resides in nature, but it's that in-between world, between the simple and the complex, where we find beauty. And it can come there in molecules. It can come in simple shapes, in complex smokes and orders. You can think about what makes that picture in a center more interesting than just a straight picture of some crystals. Beauty resides in all of these. It is there in molecules. It is there in the shapes that human beings fashion out of molecules and out of more complex matter. Thank you.
So I'm going to be, can you hear? I'm going to be speaking to you about dissonance in music and the beauty of dissonance. And as our wonderful speakers have been talking, I've kind of been frantically rethinking my remarks in my head to try to, because there's so much that resonates in the scientific and the artistic world with what happens in music. Professor Hoffman talked about looking inside of things. That's what we're going to do, except we're not looking, we're listening. We got no PowerPoint, ears only. And we're going to listen inside of musical harmony, and we're going to learn a little bit about dissonance and what it is, and you know you love it, right? I mean, don't you love this? Or this one? Or how about this one? And I'm going to show you where those sounds fit into music and, in fact, are beautiful, and you will love them. Even though isolated, they sound like they conflict and clash. In fact, this one right here, that interval, the space between those two notes, used to be known as the devil in music. It was thought that it was so awful, right? Listen to that sound. You know that one? What is that? Maria. Yeah, so Leonard Bernstein is having a good time taking the devil in music and turning it into a love song. So I'm going to have to sit down here. I am not a pianist, but I'm good enough to show you some chords and what's happening. So the first thing we need to talk about, before we even talk about dissonance, and I'll say about dissonance that I think Justice Frankfurter might say, I don't know how to define it, but I know when I hear it, right? And that's certainly the case. Let's start by talking about what it means to have music in a key. So if I go like this, that's a simple note, and we don't know what key we're in because that note here could be part of this. Right? There it is. And I think you'll hear that that is the home bass. Right? So one note alone does not tell us where our home base is, but a chord can tell us where our home base is, right? Although actually, if that's a chord and you think that's home base, I can say, well, actually that was our home base, and that's just somewhere on the way to our home base. So context is what tells us where we are situated in music. And really what we're going to be developing here is a sense of musical context. How composers can expand the lushness of what they're writing so that we're not just existing in a world, for instance, like this. Like countless really bad pop tunes that have that harmony, and you're not really situated anywhere. And if you're trying to express the joy of being on the beach in California, that's a great set of chords to use, because they don't go anywhere, right? But I can make them go somewhere. And now we're home, clearly, right? And that sound is recognizable to anybody who's heard Beethoven symphonies. And they do that 100 times at the end, saying, home, 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 we're home. That progression in music is known as 5-1. The chord based on this note is the fifth. 1, 2, 3, 4, 5. Back to home. 1. 5-1. That's our basic move to show where our home is. And I could do it this way, which does the trick, but doesn't this do it a little better? That's a dissonant note. If I came out here and I said, hey, how do you like this interval? Probably most of you, if we took a poll, most of you would say, well, frankly, I don't like the sound of that. Sounds ugly. But suddenly it has the power to go somewhere. So when we're listening to musical harmony, we're asking, when are we home and when are we traveling? And the dissonant note can help to move us. And this works. You've probably heard of major and minor. So here's the different sound. Here's a major chord, and here's a minor chord. Right? In elementary school in your music class, you learn happy sound, sad sound, which is about as good as anybody can get to telling you, describing those. The same 5 chord can go either place. Here's our 5 chord. Is that major or minor? Major. Minor. Right? The same journey leads us to major or minor. So here's a very simple harmonic progression. Right? That could be a hymn, correct? Very simple, easy. You can tell that that's home base. I'm never going to go like this. Say, thank you very much. That's the end of the hymn. You would never believe it. We need to go here or here. right? Now, let me do something to that progression that makes it very dissonant, but in a way that I think you'll find really exciting. I hope so. This chord right here, let me bunch it up a little bit. That's the chord. So again, if I come out here and I say, hey, here's my harmony, how do you like it? You're going to say, well, it clashes, it's ugly, but in this context, it's pretty nice. That's a technique where we hold the home, we don't let it move, everything else moves. It's called pedal point, because on the organ, you use the pedal to play the low note, and you just hang out there. So there's an example of a simple progression piled with some dissonance that suddenly has a lot of tension to it. And Bach, in his writing, would use that a lot at the end of his fugues. At the end of these complex melodic and harmonic developments, all of a sudden you get home and you get... and everybody goes, oh my God, I love Bach. Right? It's the use of dissonance that just heightens the experience of being home. Here's some other kinds of dissonance. Dissonance being conflict with resolution. So if I say to you, how do you like this? You might say it sounds like chopsticks. You might say, well, I'm not wild about it, but let me put it in a context. All of a sudden, that sound, because it's going there, and that sound, which is even harsher, is going there, right? And because it's a pattern, we're able to say, oh, I see there's musical motion there. So dissonance is used to avoid having just this kind of happy time sounds. We start getting more of an interesting palette, almost like putting some insects in a work of art. So now I'm almost at the end because we want to hear some actual music. But I want to talk about changing key, because changing key is what makes all music not start and only be here in our home key. We want to go elsewhere. And we use dissonance to get there. So that second chord with a little dissonance, that shoves us here. If I told you that's our home key, you'd believe me, right? But we started here. That's our home key. You agree? Raise your hand if you agree. That's our home key. Good. That's our home key, right? But no, that was our home key. So we've moved home bases. You can't do it unless you put some new conflict in and resolve it. There would be no art without conflict. There would be no chemistry without conflict. This is life inside of music, inside of harmony. I want to show you another quick thing that I think you're going to like. That sound. I won't even bother telling you the name of that, but that's a sound that you probably recognize from, say, I Dream of Jeannie. Do you remember back when we used to live on the beach? That's one of those, the TV screen starts waving and when there's a flashback, we use this. And I just want to, this is the last thing the second to last thing I'm going to show you before we move on to the music. This chord can go to 4 different places, and I just want to show you. Any of these 4 notes can be lowered by a half a tone, and it's going to send us somewhere. Listen, I'll lower this by a half a tone to here. That works for you, right? Okay. How about if we do this one? I'll lower this one. You convinced? That took us there. How about this one? The third one. Sorry. Let me do that again. Convinced? How about the top one? Convinced? That's like a 4-way intersection, that chord. You'll hear this chord, yo! Wagner operas. Everywhere. Why? Why are romantic composers using chords like this? Because they can turn any corner they want. They need that dissonance to be able to have a choice point to make the music interesting, to make it move to different keys. The only other thing I want to show you about dissonance is just the raw sound of it can be really, really cool. And since our symphony orchestra at the School of Music is about to perform the Rite of Spring on Sunday night, I will show you a chord made up of 2 major chords. Here's one. Here's one. The distance apart they are is that devilish interval, right? So I take this chord, and I put them on top of each other, and I get Stravinsky's depiction of fierceness. Let's see if you think this is fierce. If you wanted to depict primal man doing primal things, I don't think you could get there this way. There's just something, you want to crunch it between your teeth when you hear that. So when you hear dissonance in music, think about what's the context. I don't like that sound, but what if it goes there? It resolves so beautifully, right? So always listen for the conflict. Some music will just have this. And it's supposed to be unresolved conflict. That's modern life. Not everything is resolved. But sometimes this will turn out to be a part of this. Which is beautiful. So there's beautiful in dissonance, there's ugly in dissonance, there's beauty in music, there's ugliness in music, just like in life. But always think about, what is that representing? What is the sound of the music you're hearing making you feel? Because ultimately, music and science and art bring us into the world of human emotion. And that's what's been fun about this SoundWaves, is how everything is really about what happens in our hearts. And this music is really going to, I think, reach us in that way. We're going to raise the lid of the piano. The texts for the Mahler songs will be on the screen. Hopefully you can see them. The songs are sung in German, but we have English translations. Thank you to our scientists and to our performers. This has really been great. It's always very exciting. So here is 4 songs from the Rückert Lieder by Mahler.